Okay, so today, we're going to deal with trig identities. Trig identities. That's pretty sloppy. Identities. There we go. So, example 1. We've done these before, and this is the easy stuff. We've done the hard stuff with radians, but today we're talking about in terms of degrees. So tangent of 390, we can also find that on the inner circle. Tangent of 390 is the same thing as tangent of 360 degrees plus 30 more. Okay, does that make sense? 390 is really like 360 plus 30 more. Wow. So if I need tangent of 390, it goes to 360 degrees. 30 more plus 390. Does that make sense? Tangent. There it is, right? There it is. Square root of 3 over 3. It's easy. So we want the exact value from the unit circle. So it's really the tangent of 30, which is going to be square root of 3 over 3. That's easy. No, but you're using the angle in terms of degrees to get the tangent value. Right? Secant of 60. Well, secant's 1 over the cosine value, but the cosine value, so it's 1 over the cosine of 60 degrees, right? Cosine's the x value on the unit circle. So we go to the unit circle. What's the x value? Yeah, I totally agree. X value is 1/2 things, totally right. So we're going to go 1 over 1/2. So just 2. Right, 2 over 1, which is just 2. Totally agree, okay? All right. Cotangent of negative 120 degrees. Well, there's two ways to do it. Probably the easiest way to do it is do the x over the y value, okay? So cotangent's the x over the y because the tangent's y over x. Okay, 120. So positive 120 is a rotation to here, and negative 120 degrees is a rotation to here, okay? So we need the y over the x, the x over the y, so it's going to be negative 1/2 over negative square root of 3 over 2, okay? Negative 1/2 over negative square root of 3 over 2. So it's going to be a negative 1/2 equal a negative 1/2 over a negative square root of 3 over 2. Well, a fraction over fraction.
Can you just leave it like that?
No, that's really bad looking answer. It'd be better to take it as a negative 1/2 times, because we invert and multiply. Okay. 2's cancel, and the negatives cancel. I'm really left with 1 over the square root of 3. But that's not a very good answer, is it?
I think it is.
No, that's a lousy answer. Let's rationalize it and make it look better.
It's all the same.
No, you know. That's an answer I want. That's what I want. Okay, example 2. Express sine in terms of cosine. Now, this isn't the unit circle. It's just sine in terms of cosine. So what I have to do is find something, some formula that has sine and cosine in it. So I go to my identities. In fact, the identities that I just wrote down, here's an expression that has sine and cosine in it together. So I'm going to write that down, okay? So I'm going to rewrite it as sine squared theta plus cosine squared theta is equal to 1. Now the idea is we want to have it in terms of sine, okay? So we want to express sine in terms of cosine. Well, what I want to do then is go ahead and solve for sine theta, because it says express sine in terms of cosine, right? So let's just bring this over. So subtract our cosine squared. So I have a sine squared theta is equal to 1 minus cosine squared theta. Square root it, right? Square root. And since it says sine squared, I'm going to have a plus or minus answer. I'll have a sine of theta, bad looking sine, sorry about that. Sine of theta is equal to plus or minus the square root of 1 minus cosine squared theta.
Is that the answer?
That's the answer. I have sine in terms of cosine, don't I? I have sine equal to some cosine
So why
thing.
is it still squared?
This one's still squared because I just brought over, right? Oh man, what a good question. You do ask good questions. I'm glad you do this, really. Super glad you asked these questions. Okay, I want to give you an example, okay? I'm going to do it on the whiteboard because it's easier, okay? No, I'm dead seriously. You asked really good questions. A lot of kids just say whatever if you say so, right?
Okay.
I like it when you ask questions. Okay, let's do something like this. 3 squared plus 4 squared square root, okay?
Yes.
What's the answer? Is it 7?
No.
What is the answer?
So
What do you have to do first?
put down square root.
9 plus 16, right? And then what do you have to do next? You have to add them, right? You have to add them. So this problem here lies right with the subtract, okay? You have to subtract them before you can square root them, right?
Okay, so
And-
it's not first.
Right, it has to do that order of operations, right? Remember the order of operations? So you have to do what's inside before you take care of that, and you can't really do anything inside, so you're stuck with it, right? Because you know the answer here is not 7, right? You can't cancel. You actually have to work it out on the inside. And since you get to right here and you can't subtract them, you stop. You have to stop, okay? Good question. Okay, now the next one is express tangent in terms of sine. So to do tangent in terms of sine, well, I've got to come up with some expression for tangent. And if I look at my notes, and I had just circle, remember? Highlight it. Let's write tangent as a sine over cosine, and then I'll probably be able to kick out the cosine in a second. So first of all, let's write this as tangent of theta is equal to sine over cosine. Okay, now it says express tangent in terms of sine. So sine's okay, but not cosine. So I got tangent sine over cosine, but not cosine. I got to get rid of the cosine because I want its tangent just in terms of sine. So how do I do that? Well, I go back up to this little formula here. I'm going to snag that formula there, and that formula is the sine squared theta plus cosine squared theta equals 1. And I'm going to solve for cosine this time. Last time I solved for sine, but this time I solve for cosine, so I'll do the same thing. I'll bring over this sine squared, because I want to be able to solve for cosine. If I solve for cosine here, I can put it in there. I can take my answer, put it in there, and then everything's in terms of sine. So bring it over, I'll have cosine squared theta is equal to 1 minus sine squared theta. Okay, what am I doing? I want to get rid of the cosine, because I want tangent in terms of sine. So I want to get rid of the cosine. So I'm going to continue working on this until I get cosine in terms of just sine, and I'll substitute it in. So then I'll take the square root, and cosine of theta is equal to, again, plus or minus the square root of 1 minus sine squared theta. Okay, now let's take this and plug it right there. Okay, so when I'm done, it'll be tangents and just sines. So I'm going to, all right, tangent theta is equal to sine theta all over plus or minus the square root of 1 minus sine squared theta. And that is tangent in terms of sines. Tangent in terms of sines, because it's just tangent, it's just sines, okay? These are a little bit harder, aren't they?
What is this?
We're getting close to the next chapter, and the next chapter is all trig identities. So it's starting to introduce us to the next chapter. Okay, and there is a point later, okay? Great question, Will. There is, yeah. Okay, ready to turn the page? Okay, now, example 4. So if tangent of theta is equal to 2/3, it's in quadrant 3. Now, when I see these, I know you guys are paying attention. Stefan, Lane, you guys are paying attention.
Yeah.
So when I see this, when I see quadrant anything, I draw a graph, okay? I see quadrant anything, the very first thing I do is I draw a graph. Quadrant 3 is over here, right? I'm going to draw a triangle, right triangle, because tangent, sine, and cosine all come from right triangles, right? Sine, cosine, tangent all come from right triangles. My reference angle theta is there. Ooh, reference angle. That's the way we learned about the reference angle. Theta is there. Okay. Now tangent's got to be opposite over adjacent. Okay. Okay. So tangent's opposite over adjacent, except for one small thing. These both have to be negative. They have to be, because the only way I can get into quadrant 3 is I have to go back and down, right? So they both have to be negative. Now, why aren't they negative here? Well, because the negative's canceled, right? They're not negative here because the negative's canceled, but it really does need to be negative 3, negative 2 to get me into quadrant 3, okay? Now I'm missing the r, I'm missing the radius, okay? So let's find r. So by Pythagorean's theorem, r is equal to the square root of negative 2 squared plus negative 3 squared, right? Again, if I go back to my reading, in my identities, tells me r is equal to x squared plus y squared, right? That's in my reading. So my r is going to equal the square root of 4 plus 9, or it's going to be the square root of 13, okay? Now I want all of the 5 trig ratios. So what I want are all of these. I want all of these, okay? The trig ratios. I've got one of them. Oh yeah, but they're easy, okay? So let's write down what I know. I know my x is -3, and I know my y is -2, and I know my r is square root of 13. And the radius is always positive, okay? Square root of 13, okay? So I'm going to write down what I know. I know x is -3, y is -2, and the radius is square root of 13, okay? Am I good so far? Does that make sense? So now it's just a matter of filling them in, right? So let's fill it in. Okay, this is sine of theta. Well, y over r, right? So it's just going to be -2 over the square root of 13. Or, a better answer, -2 square root of 13 over 13. Better answer, right? Because there's no square root stuck in the denominator, okay? Cosine of theta. Let's see, cosine of theta. Check my notes. Cosine is the x over the r, right? So that's easy. It's going to be my -3 over my square root of 13, or better answer would be -3 square root of 13 over 13. Okay,
So
just
are you going to accept both answers?
I wouldn't like that answer. That
What will you give us?
I might give that one.
Is that a yes or no?
Yeah, probably yes. Okay, cosecant of theta. Let's see, cosecant is the r over the y, right? It's the r over the y. So the r is square root of 13 over the y, which is -2. Okay. Secant of theta. Let's see, secant of theta according to my notes. Secant's the r of the x, right? So that's easy. It's going to be my square root of 13 over my x value, which is -3. And finally, I got to squeeze in, because I got 1, 2, 3, 4. I need the fifth one, which is going to be cotangent of theta. I've already done tangent, right? Don't need tangent. Tangent's done. But cotangent of theta, let me look at my notes. Cotangent's the x over the y, right? So the x over the y is going to be my -3 over -2. Or if you cancel the negatives, right? Just 3 over 2, okay? There's 1, 2, 3, 4, and there's the fifth answer, okay? Okay, example number 5, the easiest of them all. Area. Easy. The formula area is equal to 1/2 adjacent times the adjacent times the sine of theta. Degree mode, right? Degrees. We have to be in degrees because our angle is given to us in terms of 56 degrees. So I'm just going to go area is equal to 1/2 times 12 times 14 sine of 56 degrees. And we're going to use our calculator. 0.5 times 12 times 14 times the sine 56. I get an answer about 69.6. 69.6 centimeters squared. Not too bad. Okay. Here's our homework. Okay. Make sure you show your work. Draw the pictures, all right, for full credit. I will be gone